In topic 1.10, we're going to talk about this concept of the 10% rule as it relates to energy flow in ecosystems. But let's start with a definition, biomass. When we talk about biomass, we're talking about how much energy or mass is contained in a given organism, population, ecosystem, trophic level. It's a measurement of energy. It can also be expressed as mass in terms of the units, kilograms of carbon, or it can be expressed as energy, joules of energy. And as we sort of talked about already, we know that when one organism consumes another, only about 10% of the energy contained in that organism that's consumed actually can be processed and added to biomass, added to growth or reproduction. 90% of the energy when one organism consumes another gets used up, gets converted to heat, is necessary to keep basic life processes going. Some of that matter that's ingested is indigestible. Okay? And so what's left over, that 10% or so, is what can be used for the organism to grow larger in mass or to be used towards reproduction to produce new organisms. That's what's available to the next trophic level. So what that means is if we look at an ecosystem, we can create these pyramids that show the biomass or the energy at different trophic levels. So we see here this producer has 10,000 joules of stored energy in its matter. When we look at the next trophic level, the primary consumers, the herbivores like this zebra, they would have about 1,000 joules of energy stored. About 10% makes it to this next level. And then only about 10% of that 1,000 joules makes it to the secondary consumers, the carnivores here in this case, the lion. So there's only 100 joules available there. So this concept, this 10% rule, really limits how many trophic levels you can have. Because energy is lost each step of the way, eventually too much energy is lost in the ecosystem and no further trophic levels can be supported. And here we have an aquatic version of this where we have the producers submerged in a lake or something. We have 2,000 grams. We have primary consumers, the secondary consumers, the tertiary consumers. Now you'll notice here also the numbers don't work out perfectly. It's actually not always 10%. In fact, it probably rarely is. Okay, the numbers, the actual efficiency of conversion from one trophic level to another varies based on the predator, based on the prey, etc. There's lots of factors that influence this. It's also a reason why we typically see fewer organisms that are at the top of their food chain. We don't see large herds of lions running around. Or think about other large predators, sharks. We don't see schools of hundreds of sharks in one area. That's because they require a very large range of geographic area to support their energy needs. And therefore, there just can't be very many of them.